They go tell you in number one, they give you this 9 hours. What's the 9 hours? If you read through the problem, that's just the fancy way of telling us the what? Minimum's 9. All right. And I don't expect you to write it down. I'm just going to keep track of what we have. Minimum's 9. I keep reading through. The next number I see is 15. And 15's the what? That's the max. Again, they're just putting it with hours of daylight here. They're still giving you the min and the max here. And what are we asking for at the end? Amplitude, which is another name for what variable? That's our A value. Nothing's changing except it's a little bit longer to read. How do we find our A value? We've been finding it the same way all unit. Let's go. Buckling down. 9, how do I find the A value? Max minus min divided by 2. Once I understand the formula, remember it, it's pretty darn easy now. So you got 15 minus 9 over 2. Amplitude for this problem will be 13. 3. Just a matter of reading through all the garbage, all the cute stories, and figuring out what those numbers mean. No issues there. All right, they do get a little bit more complex, and you will have to graph a couple of them. What I love to, me personally, I love to give you these high tide, low tide problems because they mimic cosine and sine. You know, hey, we start at high tide, low tide, back to high tide. Let's do it again, back to high tide, back to high tide. All right, so let's read through it. We got tides. I give you, it's a cosine curve. First number I see is 36. 36 is the what here? Just the max. I don't care if it's the max depth of the water, but max, there's your max. And then I see another number, 22. That's my minimum. So again, similar to number one, I'm giving you max and min, but now I give you a third number. And this is where it might complicate things for you guys. 12. 12. Ready? High tide hits every 12. 12. 12. 12. That's a fancy word for what? Well, every 12 hours I get back to where I started. Every 12 hours I'm back to where I started. This is the what? Period. Yes. That's the period. Don't answer any of the questions. I want to give you a heads up here. This happens a ton. Let's say instead of high tide every 12 hours, ready? High tide to low tide is 12 hours. What would be my period then? If high to low is 12. So from here to here is only 12 hours. 12 wouldn't be the period anymore. What would it be? Another 12, so a total of 24. Everyone see that? Be careful of that. That's only half when they give you high to low. That's only half of it. All right, you need to double it to get to the full period. All right, a full period is high tide to high tide or low tide to low tide, not halfway in between. All right, so watch out for that. All right, so period's 12. I'm going to do part B with you first because I'd rather do that than graph first. So part B is find the A, B, and C value for me. A, C, and then we'll do B. Even though we've already done it today, remind me, how do I find the A value again? 1, how do I find the A value? What's the formula? Max minus min divided by 2. And then somebody, how about the C value? And then you guys can find them on your own. 2. Max plus min divided by 2. Yep. And then you guys can find those out on your own right now, and then I'll ask what you got. Okay, A and C value. What do you have for me? 13, A and C value when you're ready.
7 and 29.
7 and 29 look good to me. And B value. What formula have we been using that contains B, frequency? 5
2 pi over B.
equals what?
P.
P, right? P equals 2 pi over B. We've already said above, the period is 12. High tide to high tide is 1 period. So you guys need to cross multiply like we've been doing all unit long, and let me know what the B value is.
Yeah.
Cross multiply, divide by 12. What's your B value? Frequency. 5
Pi over 6.
pi over 6. Everyone all right? The problem doesn't ask it, but I want it. Write the equation now. I don't care. The problem's not asking. I'm going to ask it. Y equals 10.
Not here.
Okay. Let's move on to 9. Y equals
7.
Yep.
Cosine pi over 6 B.
B. That is your B value.
Oh, pi over 6 X.
X, yep.
Plus 29.
Okay, there's the equation. We're all good? A, B, and C plugged in. Are you ready to graph with me now? Ready to graph? Okay, we've gone over this a ton. Probably not enough, right? All set? See you. Thanks, bud. Y-axis. What's 3 things that have to go on your Y-axis? Min and max, along with what?
Midline.
Midline. What is the midline? We just found it out. Midline is, oh, come on. How many times do we say this? Midline equals your shift equals your C value. What's my C value? Okay, so we need, ready? We need 22, 36, and 29 on the Y-axis. You go by what you got to go by. It's got to be on there, though. You want to go by everyone is 2, everyone is 3. I don't care, but 29, 36, and 22 have to be found somewhere on your graph. It depends on what you want to go by. Obviously, you can't go by ones because I don't think 36 will fit. So I'm not going to figure it out for you. Everyone is 2, everyone is 3, everyone is 4. Try to space it out, though. And 22, 29, and 36 don't have to fall on an actual line like this. It doesn't, as long as it's between something and you can graph it. And use the full graph. You don't have to stop at the top of the arrow. Got your Y-axis all done? Almost. Make sure you got those 3 values. Okay, how about your X-axis? Well, first of all, take a look. Go back to part A. What's it say? Sketch a graph of this scenario for 2 full periods, right? 2. So I got to go and then go again. So I'm going to have 8 marks on this diagram. I should have 8. 2, 3, 4. There's 1 period. 1, 2, 3, 4. Second period. All right. Teach me how to label. What do I need to do to label my X-axis? How do I find what numbers go there? Five. How do I figure out what numbers go on my x-axis?
You can. Well, you go like you start with like the pi over 2.
I got a different frequency though. So what's the period, Clayton?
12.
So that means 1, 2, 3. It should end at 12 here, right? How do I figure out here though? I'm cutting up into equal parts of what?
You divide it by 4.
So key values, I take 12 divided by 4. That tells me I'm going by 3s now. Going by 3s. And it did. Usually I would stop at 12. Absolutely, I would stop at 12. But the problem did say 2 of them, 2 periods. And once we have everything set up, X and Y axes now, it's just your ability. Can you graph a cosine curve or not? That's it. And we've been graphing cosine curves and sine curves since day 1. All right, tell me about the cosine curve. 7, where are we starting?
Oh. It starts with even midline.
That's a sine curve.
It starts with 0.
That is a sine curve. We're doing a cosine curve, Tim. Where does cosine always start?
At the maximum.
Okay, so I'm going to start at the max, which was 36. Then where does it go?
To the midline.
Midline, which we already said was 29. Then where?
Learn the minimum.
Minimum, which is 22. Then where? You got, go ahead, back to midline. And then where does the cosine curve end?
It ends at the maximum.
Maximum, yep, right here. And then there's 1. It's at 2 periods, so let's do it all over again. Oops. Any questions? Setting up your x-axis, setting up the y, and then graphing these points because it's a cosine curve. All right, one more, and then I'll do the same thing I did yesterday, come around and sit with every group. All right, little yo-yo now, huh? Good old days. Cosine curve. Part A, what's the max and the min? Okay, use the equation of this yo-yo for the max and the min. Again, fancy, cute story about a yo-yo, but I just want to know the max and the min, so we got to know what values to pluck off that equation and how to use them. All right, 6, no, 6, here we go. How can I get the max off that equation?
Each equals 1.75 is 2.25.
It was 1.75, right, everyone? It was 1.75 before I did the old shift of up 2.25. All right, Ryan, what's the new max then?
4.
Yep. And somebody fill us in on how to get the minimum now. 8, how can I get the minimum?
2.25, so negative 1.75.
Yep, it was negative 1.75 originally, but then I did the shift to 2.25. And what's my new minimum when you have it, Nora? 0.5, yep, good work. Anything? And then part B, how much time does it take the yo-yo to get back to the max? This is just a fancy way of me of asking you for something. Remember, it's a cosine curve, so where did it start? At the max. How long does it take to get back to the max? What's this a fancy way of saying here? I could have just asked for the what simply. It starts at the max because it's a cosine. I want to know when does it get back to the max. I'm just asking for the what here. Starts at the max, back to the max. That's it. I'm just asking for the period here. That's it. Just asking for the period. How do you find it? What's the formula we've been using? 12? Yep. Now I look at my equation, and I got to know where the b value is. We have an a, a b, and a c in every equation. An a, a b, and a c. Where's the b value located in this equation? Or what is it? 13?
Is it 2.25?
That's your c value, right? A is 1.75. C, 2.25. The b value is always what's with the
Is it
cosine.
The pi then?
Just pi.
Oh.
That's it. It's just pi. There's your b value, pi. And they cancel out. So it takes the yo-yo 2 seconds to get back to the max. 2 seconds. All right, here's your task today, all the way up to the bell. You're going to start with this assignment right here, 4.7. You finish it up, and it looks good for me. Delta math from yesterday, 4.6. And that's probably as far as you'll get. All right, so I'll come around, help you guys out.